This week we're going to study square root functions and inequalities. The objectives of this section are to graph and analyze the square root functions and to graph square root inequalities. So let's begin illustrating an application of square root functions. The Sunshine Skyway Bridge across Tampa Bay, Florida, is supported by 21 steel cables, each 9 inches in diameter. The amount of weight that steel cable can support is given by the equation W equals AD squared, where D is the diameter of the cable in inches and W is the weight in tons. If you need to know what diameter a steel cable should have to support a given weight, you can use the equation that is obtained out of the original one, W equals AD squared. D equals square root of W over H. So this is an application of square root functions. Let's begin graphing a really simple square root function defined by y equals square root of x, and simultaneously we're going to find the domain and the range of this function. So what value should I use for the x as an input? The values that I need to use for the x are those that guarantee that the radicand is non-negative. So we should begin the table at values of the x equals 0. So we make a table, and the first value for the x is going to be 0, and when the value of the x is 0, the value of the y is equal square root of 0, and the square root of 0 is 0. So let us plot this point, 0, 0. Then we can continue with a value is greater than 0, we can continue with 1, so the value of the x is 1, the value of the y is 1, square root of 1, that is 1. So we plot the point 1, 1. And we can continue using values like 2 or 3, but in this case, to avoid decimals, something that can be done in this case, let me give the value of x to the x, the value x equals 4. So the x is 4, the value of the y will be square root of 4, that is 2. So the point that we're going to plot is the point 4, 2. And if we think in the same way so far, that we are trying to avoid decimals, the next value for the x will be 9. So the x is 9, the square root of 93. So the point that we're going to plot is 9, 3. And we have it over here. And now that we have all the points, what we have to connect is what we have to do is to connect all the points. Take care of this fact. Begin the graphing at the point 0, 0 and extend it to the right. And the graph is going to look like this. Now, what would be the domain of this function? The x values. The domain, look at the table, are going to be all those x values that are greater than or equal to 0. So that would be the domain. And the range is the same sense. Look at the output, the y values. The outputs in this table are 0, 1, 2, 3. So the least value that we can encounter in it is 0, and outputs are going to be greater than 0. So the range is going to be all the y values that are greater than or equal to 0. Now let's look at some properties of the square root function. The square root function defined by the equation y equals a square root of x minus h plus k. And let's begin with the domain. The domain is going to be the set of all the x values that are greater than or equal to h. What I need to guarantee is that the expression under the radical symbol is greater than or equal to 0. So the value the guarantee is this, but the expression that gives us the values of the domain is this one. X has to be greater than or equal to the h value. Notice that inside of the radicand, we have the expression x minus h. And somebody may think that the value that we should set for the domain is that the x is greater than or equal to negative h. But no, what we're doing here is to take like the opposite of this expression. So the domain is the set of all x values greater than or equal to h. And what would be the range? For the range, we have two cases. The range is going to be the set of all the values that are greater than or equal to k if the value of the h is greater than 0. So if this value here, the value of the a is greater than 0, the range is going to be y greater than or equal to k. But if it happens that the value of the a is less than 0, so what happened with the graph actually is that it's reflected across the x-axis. What is going to happen with the range is that the y values, the range values, are going to be less than or equal to k. And something else that is really important in the square root function the function begins at the point h comma k. Always that you graph the square root function or a square root function, remember that this function has a beginning, and in this case the function begins at the point h comma k. Let's make an example. We can apply what we just learned. Let's graph the function y equals square root of x minus 2 plus 1. And we're going to state also the domain and the range. So let's begin. In this function, the value dA is equals 1. The 1 is the number in front of the radical symbol, so it's 1. It's an invisible number, so it's 1. The value dH is 2. Remember that is x minus what value? So minus the value 2. So that's the value dH, h equals 2. And the k value that is equals 1. So, for this reason, the domain is going to be, we know from the previous slide, that x is greater than or equal to h. So the domain values are going to be all the x values that are greater than or equal to the h value that is 2. Or if we write this in interval notation, from 2, including 2, to positive infinity. Now, what would be the range? The range, since the a is equals to 1 and 1 is greater than 0, the range is going to be the set given by y greater than or equal to k. So in this case, y is going to be greater than or equal to the k value that is 1, or if we use this in interval notation from 1 to positive infinity. And the first point in the graph is going to be the point h comma k, and the point h comma k is formed by 2 comma 1. Now that we have these properties of the square root function, we can make a table of values. And remember that the first value in the table of values must be it must be the first value in the domain. And the first value in the domain is 2. So we're going to have 2 in the table and any value above 2. And here we have a table values that we're going to use for this graphing. And we're using for this 2, 3, 4, 6, 8, and 11. You can choose your own points for making the graph. Try to have minimum 4 or 5 points in the table. The more number of points that you have, the more precise the graph is going to look. And here we have 1, 2, 3, 4, 5, and 6. So let's begin with the x equals 2. If the value of the x is 2, the value of the y would be equal square root of, replacing the x by 2, 2 minus 2 inside of the radical plus 1. The square root of 2 minus 2 is the square root of 0 plus 1, so 0 plus 1 is 1. So the value of the y is 1 when the x is 2. If the x is 3, y becomes equals square root of 3 minus 2 plus 1. The square root of 3 minus 2 is 1. The square root of 1 is 1 plus 1, it would be equals 2. When the x is 4, notice that in this case we're going to get a decimal for the y value, but it's okay, it doesn't matter. Y equals square root of 4 minus 2 plus 1. Square root of 4 minus 2 will be the square root of 2. There is approximately 1.4 plus 1, it would be 2.4. Then I skip 5 to avoid decimals, and I use 6. If I use 6, I notice that the value of the y would be exact. The square root of 6 minus 2 plus 1, it would be square root of 4. That is 2 plus 1, it would be 3. Then I skip 7, I use 8, I'm going to get a decimal. For the value of the y equals square root of 8 minus 2 plus 1, and the square root of 6, 8 minus 2 is 6, the square root of 6 is like 2.4, plus 1 it will give us 3.4. Then, to get one more point, and to avoid decimals, the value that I chose is 11 for the x, and when you use 11 for the x, the value of the y becomes square root of 11 minus 2 plus 1, 11 minus 2 is 9, square root of 9 is 3, and 3 plus 1 it would be 4. So we have this table, and the last thing that we have to do is to graph these points. So here we have the table of values, and what we're going to do is to plot the points. Let me plot first with the point 2, 1. Then continue, I'm going to plot the point 3, 2. Here we have the graph. Next, we're going to plot the point 4, 2.4. Then we can plot the point 6, 3. Then we can continue with the point 8, 3.4. And the last point that I have here, 11, 4. Once I have all the points in here, remember that this point is the beginning, so you cannot extend the graph in this direction. So what you're doing here is to connect all these points and extend it in this direction to get the graph. So the graph that it looks like this. Let's make another example about graphing, and notice that in this case the value of the a is going to be negative. So let's graph y equals negative 2 square root of x plus 1 minus 2, and let's state also domain and range. Let's begin stating the values of the a, h, and k. The value of the a is the number in front of the radical. I notice that the number in front of the radical is negative 2, so the value of the a is negative 2. Then I need to find the value of the h, and inside of the radicand is x plus 1. And the plus 1, when I take the value of the h, I take the opposite of this fact in here, this expression that I see plus 1, and the value of the h becomes negative 1. And the value of the k equals negative 2. And let's find the domain. The domain is the set of all values for x that are greater than or equal to h. So the domain is going to be x greater than or equal to negative 1, or in interval notation, negative 1 to positive infinity. Now let's find the values of the range. The range, since the value of the a is negative 2, and negative 2 is less than 0, we're going to use y less than or equal to k. This will give us the value of the range values. So y is going to be less than or equal to the k value that is negative 2, or in interval notation from negative infinity up to 2, including 2. And the first point of the graph, don't forget, we need to know the first point of the graph. It is the point given by h comma k, so the point will be negative 1, negative 2. Now we're ready to make a table of values, and the table of values, the first value that is going to see in the x, under the x, is going to be negative 1. So here we have, and in here we have several x values, negative 1, 0, 1, 3, 6, and 8. You can use any value that is greater than or equal to negative 1, so you can choose your own values. Just don't forget that it's really important that you have several points to graph, so you can improve the way that your graph looks. If the x is negative 1, the value of the y, it would be equals negative 2 times the square of negative 1 plus 1. I replace the x by negative 1 minus the 2 outside, and if I simplify this expression, the answer is negative 2. If the value of the x is 0, y becomes equals negative 2 square of 0 plus 1 minus 2, and same, if I simplify this expression, it becomes negative 4. If the value of the x is 1, the value of the y would be equals negative 2 times square root of 1 plus 1 minus 2, and this is equals, approximately equals negative 4.8. If the value of the x is 3, y equals negative 2 times square root of 3 plus 1 minus 2. This is an exact value, equals negative 6. If the value of the x is 6, the y value is negative 7.3. And if the value of the x is 8, the value of the y is negative 8. Now with these values, I'm ready to plot these points so I can get my curve. Let me plot the point negative 1, negative 2. Then let me plot the point 0, negative 4. Then 1, negative 4.8. 3, negative 6. The point 6, negative 7.3. And finally, according to the points that I have on my table, a comma negative 8. And once I have plotted these points, don't forget the fact that the first point is this one, so my graph should begin in this point and it should go in this direction. So that's why the graph at the end looks like this. Now let's define what a square root inequality is. Square root inequalities. A square root inequality is an inequality involving square roots. So let's make an example how to graph a square root inequality. So in here we have the inequality y less than square root of x minus 3 minus 2, and we need to graph it. And we have some steps to follow in order to graph this. And the first step, it is to graph the corresponding or the associated equation with the inequality. And the associated or the corresponding equation for this is y equals square root of x minus 3 minus 2. So the only thing that I did to graph or to take care of the first step is to replace the inequality symbol for y for the equal sign, and what we get is y equals square root of x minus 3 minus 2. And we need to take care of the following fact. Since the boundary should not be included, the graph should be dashed. How do I know this? Look at the inequality. The inequality that I need to graph is y less than. So if it says less than, when I made the curve it should be dashed. If it would be supposition y less than or equal to, or y greater than or equal to the boundary, this line, this graph that we're going to graph at this moment, this curve that we're going to graph at this moment should be solid, but in this case it's dashed. And the domain include values for x that are greater than or equal to 3. Remember, the domain is all the x values that are greater than or equal to the h value, and the h value in this case is 3, so the graph should include the 3 and any value that is greater than 3 for the x. And here we have the graph. Notice that we obtain this graph. You know how to obtain it by making a table of values, making a table of values for 3 or any value greater than 3, and when you make your table of values and plot the points, the graph is going to look like this. And notice that the graph is a dash graph, it's not solid. Why it is dash? Because the boundary, like we discussed at the beginning, is not included. And the step 2, we need to shade a region. And what region should be shaded? Since y is less than, the shaded region should be below the boundary. So it means that it should be this region and within the domain. So it should be including the values of the domain. So the graph is going to look like this. So what you need to do in here is to shade the region that is below and respecting this boundary also. Remember that this point in here has the value x equals 3. So when you make the shading, you should respect this, and all the values should be greater than 3. Consider these values in here. And all this region is the region that is below the boundary. And step 3, it should be like, to guarantee, this is optional, to guarantee that what you did is okay. So what we can do in here is to select a point in the shaded region and verify there is a solution of the inequality. So in here we have, I'm proposing the point 7, -2, and you can choose any point that is in this region below. So I choose the point 7, -2. So this point over here. You can see clearly that this point is on the graph, but what we're going to do is to check that is true, that is at this, in this region. So replacing it to the original inequality, that is this one, we said -2 is less than the square root of the x value, -7 minus 3 minus 2. And when we simplify this, this becomes -2 is less than the square root of 7 minus 3 is 4, the square root of 4 minus 2. And when I simplify this finally, it becomes -2 less than the square root of 4 is 2 minus 2 is 0. So -2 is less than 0. And this is a true statement, meaning that what we did is okay. The shading that we get is correct. And finally, this is the end of the section. And thanks for your attention. And I hope that everything that we have been explaining here is clear.